All right, these are the slides and lesson for Friday, January 14th, 2022. So we open up with a quiz, and I've posted a quiz. This one's just going to be a fun one as well, just to get some grades in the grade book. So that's something that can be done over this weekend. So I'm going to make it due next Friday as well. So I always start out, by telling the class, hey, let's take our headphones out, put our phones away so we can listen, make sure we're getting everything we can out of this lesson. And just remind everyone to properly wear a mask. All right. So, like I said, this is Friday's lesson for January 14th. So we're gonna talk about impulse a little bit more. So we're gonna review momentum, review impulse, then we're gonna do a coin collision lab. So you can see here, there's quite a bit of assignments that can be done. So there is that homework assignment that was due yesterday, the rocket sled challenge, the bungee lab is due today, so make sure you get those in. The coin collision lab that we're going to do today is going to be due next week, and that quiz that we're going to do this week will be due next week as well, next Friday. Just want to get some grades in the grade book, get us on a routine, no matter what type of learning we're doing. All right, so the assignments from last week, make sure you get any of that late work in. So that homework, the Arecibo challenge, and make sure you have a notebook coming in. Make sure you get those in. All right. Big question for today is, why do lacrosse players use rackets? All right. So let's just review momentum. So we all know Newton's first law: objects in motion remain in motion, and that tendency to remain in motion is called momentum. So momentum depends on not only the mass, but also how fast that mass is moving. We define momentum as the product of mass and velocity. So what does the arrow represent above that P represent? Oh, well, it is going to be a vector quantity, which means it does have a direction, and the unit for momentum is kilogram meters per second. So then we talked about, well, how do we change an object's momentum, right? How do you gain momentum? How do you lose momentum? Well, to produce a change in velocity, a net force must be applied. So to produce a change in momentum, well, you have to apply an impulse. Impulse is change in momentum. So the impulse to calculate is force times the time interval that force is applied. But impulse is also change in momentum. So we can write momentum as the mass, assuming the mass doesn't change, multiplied by the change in velocity. So if you put it all together, these three equations are all the same one. And that last one down at the bottom is the one we're going to use, right? So it's the impulse of force times the time interval equals the change in momentum, the mass times the change in velocity. So the five key components to know about impulse are, well, impulses always occur in pairs. Impulse pairs are always equal in magnitude. Impulse pairs are always oppositely directed. Impulse pairs always occur simultaneously. And impulse pairs never cancel because they act on two different objects. Right? And these should look similar, and these should look exactly the same as force pairs when we learned about Newton's third law. So let's take a look at this one. So it says, why do lacrosse players use rackets? So for this, I asked three different volunteers, and I put this up on the board. So I said, hit the bullseye. Use only your wrist. So one student's only gonna throw the ball with their wrist, right? Just using their wrist, using nothing else. One student would use their wrist and their elbow, so they could use a little bit more, and the last person can use their whole body, right? So usually I stand in front of it, so I'm catching it like they're trying to toss it to me, right? And what you should know, and you can watch the video of this, I recorded this last year, but you'll notice that when you're throwing with your wrist, well, you can't really get it to go that far. When you use your elbow and wrist, you can get it to go a little bit farther. But as you use your whole body, it'll be easy to get that object moving, right? So let's take a look at why that is. So assuming it's the same ball, same person throwing it, in which of these scenarios, using your wrist, your elbow, or the whole body, if either, does that ball have a larger mass? Well, it's going to be the same ball. Right? In which of these scenarios, the wrist, elbow, or whole body, does that ball experience a larger change of velocity? It's going to be the whole body. You throw it, it's going to have a larger change of velocity. Assuming it starts at rest, it's going to be going faster. That's why you can get it to go farther. So, in which of these scenarios does that ball experience a larger change in momentum? It's going to be that person, or the whole body, using the whole body. Now, which of these scenarios does the ball experience a larger impulse? Well, it's going to be the person using their whole body to throw it. Now, which of these scenarios does the impulse apply to the ball for the longest time, right? So this is the key to it, right? So I think I should change that to force applied all the time, but it is like the impulse applied for a time. It's going to be the whole body, right? So when you're throwing with the wrist, it's just going to be the force is just applied for that amount, right? applying with your elbow or throwing with your elbow and wrist, it's just going to be for that amount. But as you're using whole body, you're throwing over a longer period of time. You're applying that force. And yeah, your body is probably stronger than your wrist and elbow, but what makes it go a lot farther and faster is because you're applying that force for a longer period of time. Now, if that person wants to throw the ball as fast as possible, what variable would they want to try to maximize? So uh, I should probably reword this one a little bit, right? So, like, if I'm just throwing, if I'm throwing a baseball and I'm, well, assuming I just can't get any stronger, right? Instantly, what can I do to my technique to like make that ball go faster? Well, what you want to do is increase the time interval that force is applied. So that's it. Assuming that you're not getting stronger, like in that instant, what can you do? Well, you increase the technique. That's why if you're throwing a baseball, they always tell you to follow through, and it's because you're applying that force for a little bit longer. So you can see that over there. We'll notice, well, the mass remains the same. And I say the force remains about the same. You're probably throwing a little bit, probably applying a larger force if you're using your whole body. But the key to this is that you're applying a force for a longer period of time. So you can watch this video, and this is the world record for the fastest pitch in a baseball game. Now notice how he winds up and follows through and applies the force for the longest period of time possible. Now I asked this question, how could he throw the ball even faster? Well, let's take a look at this one. So this is called, I think, high halai is a sport where players use a racket known as a cesta to throw a ball, which known as a pelota, into a wall to bounce other players. So notice, like they can throw a lot faster. Like the fastest baseball pitch is like 106 miles an hour. Well, the fastest this has ever been launched is like 180 miles an hour. Well, it's not because they're stronger, right? It what it does is that because they're applying a force, it's going to be large force. Well, they're applying it for a longer period of time because they basically extended out their arm, right? So I use this as an example, right? And I have one right here. So this is called the Chuck It launcher, right? So if you have a dog, well, what you can do is notice that if I just use my wrist, well, instead of just applying the force for just that amount of time, I'm applying it for this amount of time all the way through. So essentially what that's doing is this is increasing the time interval that force is applied. So you can watch this and it's just really easy. It's like just sort of like a lazy way to throw a ball really far. So I could throw this ball across the room just by using my wrist because I'm increasing the time interval that force is applied. And this is another example of soccer throwing. So these players are doing like if they're throwing a ball in, from out of bounds, it has to go over the head and throw it. But these players are doing a flip, right? And I just want you to say, well, like which variable does flipping increase, right? So it doesn't necessarily make them stronger. It doesn't necessarily increase the force. But what flipping does is it's applying that force for a longer period of time so that ball can go really far. So now let's answer this question. What happens to momentum during a collision? So in order to do this, we're sort of switching gears, getting ready for next week. So this video is going to help you complete that lab activity. This is called coin collision. So in this one, it's going to be, pretty simple. Like all you need to do is you need to have a small coin and a large coin, right? Doesn't matter what it is. Well, I would recommend watching that video, helping you out if you have any questions. I used a quarter and a penny. You could use like a nickel and a penny. You could use a dime for the small point. It doesn't really matter. You just need one larger coin, one smaller coin. Now it says place the large coin on the table at rest. Put the small coin under your finger and slide it into the large coin. We'll just explain what happens. Now tell me which coins is/are moving after the collision and how fast and in what direction. And place the small coin on the table at rest. Put the large coin under your finger and slide it into the small coin. Explain what happens. Which coins is/are moving after the collision, how fast and what direction. So essentially one of them you're just sliding the small coin into the large coin, the next one you're sliding the large coin into the small coin, explaining what happens, right? So then you do that lab. This shouldn't really take too long, and I like this one because you can do this at home really easily because you just got to find a couple of coins lying around. But these are the conclusion questions that you should be able to answer. Well, which has more momentum? The small coin at rest on the table or the large coin at rest on the table? Explain your answer and then look at the equation for momentum. Which has more momentum? The small coin sliding on the table or the large coin sliding on the table? Explain your answer. And then in this one, I have to give a little caveat. Assume both coins have the same velocity. And this last one is sort of just like the crux of the whole lab is, well, explain what happens to the momentum of the coins during the collision. So what happens? right? So what happens? All right. So as you can see, there are a bunch of there's a lot of examples today. I recommend looking at the slides. A lot of different examples for you to go over. There's all the labs and demos. There's the coin collision, and there's resources that you can get from Physics Classroom. So just during the next couple of days over the weekend, just make sure you get the homework done from this week. Make sure you get the homework done from last week. Make sure you get those labs done. Make sure you get those quizzes done. The quiz from last week, if you weren't here on Friday, the quiz from this week, that's just another fun one. Get a grade in the grade book. So there's plenty of you to do. I don't want to give any extra stuff, but we need to take advantage of these days, like we're in class, because once we come back, we're going to hit the ground running with our next topic. So, just as a final thought, remember there's too much unknown in the universe to take a break from learning. Get out there and question everything.